All right, so in the last set of notes, we focused more on a single translation. So looking at just h or just k. So remember, we talked about y equals x squared plus k. We talked about y equals the quantity x minus h squared and what happened. So that k, just a reminder, shifts your parent function up and down, vertically up and down. The h will shift your function left or right. Okay? Now we also need to remember for h that we do opposite of what it says. K is the same. H is going to be opposite. Again, if you can print these notes, I highly recommend it. If not, you don't necessarily need everything written down, but do your best to get the important information. Okay, in the last video, we also talked about vertex form. So this is vertex form, and we're going to be graphing in vertex form all week. So we want to make sure we understand vertex form. So h is the x, h is the x value of the vertex. K is the y value of the vertex. Remember, h is opposite, k stays the same. Okay, so h is opposite, k stays the same. So we're still going to talk about orientation. Remember, orientation determines if our graph opens up or down. So if we have a positive a, we open up. If we have a negative a, we open down. Change in shape is your compression or stretch. It could still be like the parent function. So if a is equal to 1, then it's similar to our parent function. There is no change in shape. If a is between 0 and 1, then we have a compression. Our graph gets wider. And if a is greater than 1, we have a stretch. Our graph will become skinnier. We're going to talk about, again, whether it translates. And we know that from the vertex, what's happening there. We'll find the vertex and the line of symmetry, or again, we can call this the axis of symmetry. They are the same thing. Okay. So we're going to see if we can fill in a lot of this information before we actually graph it. It's good to help. And then remember, if you need to use Desmos to help you graph, you can do that as well, so that you can compare and see. So in order to find orientation and shape, we have to know what a is. Now, if we remember up here, there is an a in front of this x minus h squared. There's an a there. So the a in front of this set of parentheses is 1. So if a equals 1, okay, it's positive, so my graph is going to face up. Because it is a 1, there is no change to the shape of my graph. Okay, so I can fill that in pretty quickly. Now, in order to talk about how it's going to translate, let's talk about the vertex. Okay, so vertex, we did this in the last one. So h is the x value of the vertex. H is inside, and we always take the opposite. So negative 3 becomes a positive 3 for the vertex. K is on the outside, and it stays the same, and that's my y value. So 3, 1. Which means from my parent function, I went to the right 3, and I went up 1. Because my parent function, my vertex is at 0, 0, right? So if I start at 0, 0, I'm going to move to the right 3 and up 1 to get this new vertex. My axis of symmetry is always x equals, and it's always x equals the x value of your vertex. So I can fill in those key features without even having to graph. I can also tell you what the domain is going to be. So the domain of this function, and we're not going to necessarily write this in, but you're going to need to know it for homework. So the domain of this function is always all real numbers. range. Now, because my graph faces up, I have a low point, right? So I have a minimum. So y has to become greater than that low point, and that low point is 1. So y is greater than or equal to 1. Okay, so all of this vertex tells you pretty much everything. The vertex in A gives you all the information that you need for your graph. All right, let's create a table of values. So my vertex goes in the middle. It's 3, 1. And I'm going to choose two numbers that are less than 3 and two numbers that are greater than 3. So less than 3 are 2 and 1. Greater than 3 are 4 and 5. And I'm going to plug those in. Okay. Scratch paper. All right, so let's plug in 1. Okay, so if I plug in 1, so y equals 1 minus 3 squared plus 1. 1 minus 3 is negative 2 squared plus 1. Negative 2 squared is a positive 4 plus 1 gives me 5. So if I plug in 1, I get 5. Now remember, because of symmetry, that's going to match that term there. Now I'm going to plug in 2. So y equals 2. 2 minus 3 squared plus 1. 2 minus 3 is negative 1 squared plus 1. Negative 1 squared is 1 plus 1, which is 2. So this and that should both be 2. Okay. And let's plot those points. Now remember, my graph should open up and it shouldn't be any wider or skinnier than my parent function. If it is, then I did something wrong. So here we go. 1, 5, 2, 2, 3, 1, 4, 2, and 5, 5. Okay. All right, what I would like you to do is take a second and pause the video and see if you can identify the key features. Okay, so get as many of those key features down because again, there's not a whole lot of math when we're graphing, right? We're not doing a ton of solving, but we have to understand the vocab and the key features of these graphs in order to graph them and then obviously identify everything. So pause the video for a second and see if you can do that, and then press play when you're ready. Okay, you've taken a second to do that. I'm going to kind of just go through. So first thing I'm going to identify is my A. Remember, A is out front in front of the parentheses. So in this case, A equals 1, right? Fix that. So if A equals 1, it's positive, so my orientation is up. Because A equals 1, there is no change to the shape of my graph. Now, before I talk about how it translates, I'm going to find the vertex. So the H is inside, and that's the X value, and it's opposite. So I see a negative 2, I'm going to write a positive 2. My K value is attached at the end. That's going to be a positive 4, and that stays the same. So that tells me that my graph shifted to the right 2 and up 4. From my parent function, which is at 0, 0. My axis of symmetry is x equals the x value of the vertex, which is 2. I'm going to give you the domain and range. You may have written it or not. The domain for this is always all real numbers. And the range, because it faces up, I have a minimum. So it's y is greater than or equal to the y value of my vertex, which is 4. My vertex is going to go in the middle of my table. So 2, 4. I'm looking for two numbers that are less than 2, two numbers that are greater than 2. So less than 2 would be 1, 0. Greater than 2 would be 3 and 4. And again, we do this for symmetry. So if I plug in 0, I'm going to plug in 0, yeah. So y equals 0 minus 2 squared plus 4. 0 minus 2 is negative 2 squared plus 4. Negative 2 squared is positive 4, and 4 plus 4 gives me 8. So I have an 8, and again, because of symmetry, I have an 8 down there. I don't have to actually solve. Okay, I'm also going to plug in 1. So y equals 1 minus 2 squared plus 4. 1 minus 2 is negative 1 squared plus 4. Negative 1 squared is 1 plus 4, and that gives me 5. Okay, so this is 5, and again, I have 5 there. I'm going to plot those points. So 0, 8, 1, 5, 2, 4, 3, 5, and 4, 8. If your graph is not a U shape, you did it wrong. If it's not symmetrical, you did it wrong. So there's a lot of good checks in here to help you make sure that you are graphing these appropriately. Okay. All right, let's do number 3 together. All right. So let's identify A. So here A is a negative 1. Okay, A is negative 1. Now, the negative tells me that now my orientation is down. So when I graph this graph, it should face down. If it doesn't, I did something wrong. Okay, now the shape. When I'm talking about shape, I only look at the value of A, basically the absolute value. Okay, absolute value is your distance away from something, and that's always positive, right? Because distance can't be negative. So I'm just looking at 1. So since it's a 1, I'm going to have no change to the shape of my graph. Okay, so don't look at positive or negative when we're looking at shape. My vertex, opposite of 1 is negative 1, and then I keep the negative 2 the same, which means this graph should shift to the left 1 and down 2. Okay, left 1 and down 2. My axis of symmetry is x equals, and it's the x value of the vertex. The domain is always all real numbers. And the range, now in this case my graph is facing down, which means I have a high point, right? And everything gets lower or decreases. So it's y is less than or equal to the y value of my vertex, which is negative 2. I'm going to plug in my vertex in the center, so negative 1, negative 2, and create the table around it. So two numbers that are greater than negative 1, two numbers that are less than negative 1. So this would be 0 and 1, and negative 2 and negative 3. And you can choose whatever you want to plug in, right? But you know there's going to be symmetry, so we only have to really plug in 2. Let's plug in 0. Okay, so I have y equals negative. Now if I plug in 0, it's 0 plus 1 squared minus 2. So that negative stays. 0 plus 1 is 1. I'm going to do all the steps for this one. 1 squared is 1, but I have that negative out front, so I'm going to keep it a negative 1. Minus 2 gives me negative 3. So when I plugged in 0, I got negative 3. And guess what? If you plug in negative 2, you're going to get the same thing. Okay, let's plug in 1. So if I plug in 1, I get 1 plus 1 is 2, so 2 squared. And 2 squared is 4, But again, you have that negative out front. Minus 2, which gives you a negative 6. Negative 6. And because of symmetry, it's also for that negative 3 as well. Now, again, when I graph this, it shouldn't be skinny, it shouldn't be wide, it should be normal, and it should be facing upside down. If it's not facing upside down, we did something wrong. So let's see what happens. Ready? So negative 3, negative 6, 2, 4, 6. Negative 2, negative 3, negative 1, negative 2, 0, negative 3, and 1, negative 6. Okay, so here is this graph. So it has a normal shape, but the orientation now is down. My graph face is down. Okay, so we've really looked at key features, especially when A is equal to 1. So now we're going to focus on problems when A is not equal to 1. Okay, because we want to see what's going to happen there. And remember, the only difference is our graph either has a stretch or compression. So if A is between 0 and 1, then we have a compression. Our graph's going to get wider. That's a vertical compression. If A is greater than 1, we have a vertical stretch, so our graph gets skinnier. All right, here we go. So we're going to do the same thing, right? We're going to identify A. So in this case, the number out in front of the parentheses is a 1/2. So A is 1/2. Now, because A is positive, my orientation is up, right? It faces up, it's positive. Now my shape, when A is between 0 and 1, we have a compression, which means your graph should be wide. Okay. Now I'm going to identify my vertex the same way. Inside is the x value, and it's opposite. So I have a negative 2, which makes it a positive 2. And then the k value stays the same. That's your y value. And that's going to be a positive 1. So here I went to the right 2, and I went up 1 from my parent function. My axis of symmetry is x equals 2, the x value of your vertex. Y'all should be really good at domain right now. The domain of all of these, no matter what, don't think hard, is all real numbers. Now, because my graph is facing up, I have a minimum value, right? So everything increases. Y is greater than or equal to that y value of my vertex, which is 1. Okay, vertex in the middle, 2, 1. 2 numbers greater than 2 are 3 and 4. 2 numbers less are 1 and 0. I'm going to plug in the easier numbers, so I'm going to plug in 0 first. Let's plug in 0. Ignore my scratch paper. Y equals 1/2. 0 minus 2 squared plus 1. Okay. Y equals 0 minus 2 is negative 2, right? And negative 2 squared is 4. Half of 4 is 2. And 2 plus 1 gives me 3. So when I plug in 0, I get 3. And if you plugged in 4, you're going to get the same thing. All right, let's plug in 1. So 1 minus 2 squared plus 1. All right, here we go. 1 minus 2 is negative 1 squared. And negative 1 squared is a positive 1. Okay, now half of 1, or 1/2 times 1 is 1/2 or 0.5. And 0.5 plus 1 is 1.5. So we could have decimals. Okay, so this is going to be 1.5 and this is going to be 1.5. So when we graph, we're just going to guesstimate the best we can in our graph. All right, so 0, 3 is going to be my first point. Now, my graph should open up, right? And it's going to be a compression, so it's wider than my normal graph. So it should be wider than all the graphs on the front side. All right, 0, 3, and then 1, 1.5. So you're going to go in the middle of a box there. 2, 1, 3, 1.5, and 4, 3. Okay, this graph is definitely a little wider. It faces up. So we are good to go there. All right, I want you to pause the video and I want you to complete number 5. Get everything done. The orientation, the shape, how it translates, vertex, axis of symmetry. I'd like you to identify the domain and range, create a table of values, and graph. When you play the video, I'm just going to come back and kind of go through all of those quickly. So really, really try to get as much of that done. So pause the video and see how much of that you can do. All right, let's see how you did. Okay, so first thing, hopefully you identified A as -2. The number out in front is -2. Because it's negative, our orientation is down. So my graph is going to face down. Now, when I'm looking for shape, I am just looking at the value. So I'm just looking at the 2 part. Okay, so because A is greater than 1, right? It's a 2. I don't worry about the negative. Don't worry about the negative. So because A is greater than 1 and it's 2, I am now going to have a stretch. My graph is going to be skinnier. My vertex, change the sign for what's inside. So that's going to be a +1. Keep the sign on the outside, gives me a 3. So I move to the right one and up 3. My axis of symmetry is x equals, and it's always x equals the x value of the vertex. So in this case, it's x equals 1. Your domain is always all real numbers. And your range. So in this case, I have a maximum value because my graph is facing down. So I have a high point, which means everything is now going to be less than or equal to that point. And that value is 3. So y is less than or equal to 3. Your vertex goes in the middle. You have 1, 3. Hopefully you chose 2 points that are smaller than 1, which are 0 and -1, and 2 points that are greater than 1, which are 2 and 3. Now I'm not going to plug them in here because you plug them in, right? If you plug in 0, you get 1, which means there's symmetry there. And if you plug in -1, you get -5. Now before I graph, I know that my graph should face down and it should be skinnier than the parent function. If it's not 2 of those things, then I did something wrong. Okay? So -1, -5, 0, 1, 1, 3, 2, 1, 3, -5. Okay, it faces down. It's skinnier than my parent function. And also remember that you can always use Desmos to help check these answers and see if you're graphing them right. Okay, so you can go through that way as well. All right, we are almost done. Last problem, we're going to do it together. Here we go. So here I have A equals a +2/3. Because it is positive, remember your orientation is up. 2/3. So 2/3 is between 0 and 1, right? It's less than 1, which means I'm going to have a compression. My graph's going to be wider than the parent function. Vertex. Inside the parentheses, I take the opposite, so I have a -1. Outside, I keep it the same, so it's a -2, which means I'm moving to the left one and down 2. The axis of symmetry is x equals -1. So the x value of the vertex. Your domain. All real numbers. Your range. Now, because it faces up, we have a minimum value, so all my values increase. So y is greater than or equal to that lowest point, which is -2. Okay. So, vertex, -1, -2. Two numbers that are smaller than -2 are -2 and -3. Two numbers greater are 0 and 1. All right, let's plug in 0. Okay, so 2/3, 0 plus 1 is 1. Okay, 1 squared is 1. And 2/3 times 2/3 is 2/3. Now, because we're graphing, it is logical to put this as a decimal. Okay, so in your calculator, because it's really just 2/3 times 1, I would figure out what 2/3 is. Okay, so 0.67, and I'm going to subtract 2 from that, right? Because 0.67 minus 2 gives me a -1.3. So if I plug in 0, I get a -1.3. You don't need to get all fancy and keep it as a fraction. You just need to be able to graph it. Okay, so we're going to put a -1.3. I'm going to also plug in 1. So 1 plus 1 is 2. 2 squared is 4. Now again, we don't need to keep it fancy. So in your calculator, 2/3, you're going to want to put in parentheses, times 4. Gives you 0.267. Okay, so that's all of this. And I'm going to subtract 2 from that, giving me 0.67 or 0.7. Either one is fine, because really we're just guesstimating on our actual graph. All right, here we go. -3 and then 0.67. So it's more than 1/2 but less than 1. Just guess on your graph, okay? So don't quite go at 1. It's going to be a little more than 1/2. -2 and then -1.3. -1, -2. Now, the big thing is you want to make sure that you're even on the other side. So if this point right here was my -1.3, I need to make sure when I go 0, -1.3, it's in the same spot, right? Because there should be symmetry. Same with 1 and 0.67. It should be in the same spot for symmetry. Okay, so my graph faces up. It's a little wider than that parent function, so I'm pretty sure I did that accurately. And again, if you need to, use Desmos, and Desmos can help you verify. It won't give you all of the key features that you need to know, but it at least can help you verify your graph.